The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, so today we're going to be reviewing for the Chapter 5 test. Just a reminder, the test is on Monday. There will be no class Zoom meeting Monday at 10:30. So if you show up, you'll be very lonely. Your test is due no later than 11:59 p.m. Monday night. You can take it over the weekend if you want, or take it Monday. Just make sure you've got, an hour and 15 minutes worth of time set aside where you won't be disturbed. The first thing I'm going to do today is I had some questions that actually go back to section 5.8. Part 1. So I'm going to start by looking at those, and then I will open it up to any other questions you might have. So this is from section 5.8, part 1, and we're going to start off with number 11. And it says the following: divide the polynomial by the monomial, simplify your answer completely. And what we have is this: negative 15 x squared y cubed plus 18 xy squared minus 3xy, all divided by negative 3 x squared y squared. Now, recall, when you're dividing a polynomial by a monomial, you take each term in the numerator and divide it by the monomial in the denominator. So this fraction becomes negative 15x squared y cubed divided by negative 3x squared y squared plus 18xy squared divided by negative 3x squared y squared minus 3xy divided by negative 3x squared y squared. So now we'll go across and simplify each separate fraction. Okay, so the first fraction, negative 15 divided by negative 3, negative 3, reduces down to 5 over 1. X squared divided by x squared reduces down to either x to the 0 power, which is equal to 1, or just plain old 1. We'll just go with plain old 1. And then y cubed divided by y squared would be y to the 3 minus 2 power, or y to the 1 power, or just y over 1. So that first term becomes 5y. All right, moving on to the second term. We've got plus 18 divided by negative 3 would reduce down to negative 6 over 1. X divided by x squared would be x to the 1 minus 2 power, which would be x to the negative 1. Y squared divided by y squared would be y to the 0 power, which is 1, or just plain old 1 anyway. So now I've got what? Negative 6x to the negative 1. Okay? But that could be written as negative 6 over x to the positive 1. So we could say 5y minus 6 over x. So far, okay? Let's go on to the third term. Okay, we've got a minus sign, and then 3 divided by negative 3 would reduce down to negative 1 over 1. X divided by x squared would be x to the 1 minus 2, or x to the negative 1 power. Y over y squared would be y to the negative 1 power as well. But I could rewrite that as negative 1, and then x to the negative 1 would be x to the positive 1 on the bottom. Y to the negative 1 on top would be y to the positive 1 on the bottom. Okay. Subtracting a negative would be like adding a positive, okay? And I don't need those implied 1 exponents. So here is my final answer. 5y minus 6 over x plus 1 over xy. All right, now we're going to take a look at number 14 from that same assignment. Okay, so here's number 14, and it says, perform the division. 2x squared plus 5x plus 2 divided by 2x plus 3. So now we're dividing a polynomial by a polynomial. So we're going to use long division. The numerator and denominator, the dividend and the divisor, are both in descending powers, standard form. There's no missing terms. So I'm going to have 2x plus 3 on the outside and 2x squared plus 5x plus 2 on the inside. So we take a look at the leading term inside divided by the leading term outside. 2x squared divided by 2x equals 1x, which goes up here in the x to the first power column. Then we take that x times the 2x plus 3, distributing, we get 2x squared plus 3x, which we put over here down below. Then we subtract that quantity from what's up above, but we distribute the subtraction sign, change it to addition of the opposite. We get 2x squared plus negative 2x squared, which is 0x squared. Then in the next column, 5x plus negative 3x, which is a positive 2x. Bring down the next term, plus 2. Okay. So then we're going to take the leading term divided by the leading term. 2x divided by 2x is 1, so it's a plus 1. 1 times 2x plus 3 is 2x plus 3, which we write up here. Then we're going to subtract that quantity from what's up above, change it to addition of the opposite, add up the columns. 2x plus negative 2x is 0. 2 plus negative 3 is negative 1. So I've got, and I'm looking here, I'm seeing that in WebAssign, this particular one, rather than putting the negative sign in the fraction, they wrote it like this: x plus 1 minus 1 over 2x plus 3. Okay, so here's minus. So that would be the final answer. Any questions about that one before I go on to the next one? All right. And finally, we've got number 15 from that same assignment. Perform the division. 6x squared minus 11x plus 1 divided by 3x minus 1. Again, the dividend and the divisor, the numerator and the denominator, are both in descending powers. And again, there's no missing terms, no missing powers of x. So we're going to have 3x minus 1 on the outside, 6x squared minus 11x plus 1 on the inside. Okay. And let's see, 6x squared divided by 3x. 6x squared divided by 3x would be 2x. So that goes up there. 2x times the quantity 3x minus 1 becomes 6x squared minus 2x. So 6x squared minus 2x. We're going to subtract that quantity from what's up above, change it to addition of the opposite, add up the columns, we get 0x squared and negative 9x, bring down the next term, plus 1. Then we're going to take the leading term inside, negative 9x divided by the leading term outside, 3x, which gives us a minus 3. Then we take negative 3 times 3x minus 1, negative 9x plus 3, negative 9x plus 3. Subtract that quantity from what's up above, change it to addition of the opposite, we get 0. x, and let's see, 1 plus -3 is -2. So 2x minus 3 minus 2 over 3x minus 1. Okay, and there's the answer. Any questions about that particular problem? Okay, those were all the questions that people emailed to me. So now I'll open it up to you folks. Is there anything you'd like to look at from 5.8 part 2, the chapter review, anything at all? This is your time for review. So have at it if you've got any questions. This is going to be a short meeting. Is there anything you'd like me to just talk about in general to do with this chapter?
Would we be able to do one with like a division problem?
Okay. Like
Sorry,
the ones we just
not a
reviewed?
division problem. Sorry, no,
What's
no,
that?
no. Not a division problem. Sorry, it's a oh, what is it called? Well, we find the x and y intercepts, and I remember like in the beginning, I don't know, last week, like we had a graph the line, but the line was like in the form of a U.
Oh, okay. Yes, so we were graphing parabolas.
There you go.
So you want to look at one of those?
Yeah.
Okay, all right. Let's see here. Let's do this. Let's graph y equals x squared minus 4. Okay. Now, as I've said before, when we're just starting out graphing something that we don't know a whole lot about, and let me back up a little bit. Later on, chapter 10, we're going to go into extensive discussion about procedures and graphing these things. But for right now, I'm just going to use a table, and I'm going to use x going from -3 to +3. Okay. So if x is -3, and I'm going to write my stuff over here on the other side. Okay. If x is -3, I'd get y equals -3, the quantity squared, minus 4, which would be 9 minus 4, or 5. So we've got the point -3, 5. You okay with that?
Yes.
All right. If x is -2, y equals -2, the quantity squared, minus 4, which is 4 minus 4, which is 0. So -2, 0. If x is -1, let's do this, y equals -1, the quantity squared, minus 4, which is 1 minus 4, which is -3. If x is 0, y equals 0 squared minus 4, which is 0 minus 4, which is -4. If x is 1, y equals 1 squared minus 4, which is 1 minus 4, which is -3. If x is 2, y equals 2 squared minus 4, which is 4 minus 4, which is 0. And I'll come back over here. If x is 3, y is 3 squared minus 4, 9 minus 4, which is 5. And so, let's see if I can get my curve to line up there. Got this handy dandy tool here that works quite well sometimes. And let's see here. Okay, and there's our graph. So is that what you wanted, I hope? Vanessa?
Yes.
Yeah. Do you want any more of those?
No, it's pretty, I just wanted to review it real quick
Sure.
because I was going through my notes and I'm
Mhm.
like, wait, how did we get from there? But
Sure.
I didn't realize that we did the -3 on the y section all the way to +3.
Yeah. Okay.
But yeah, thank you.
What else?
I'd love if you did another binomial divided by a monomial with like multiple variables.
Okay, so a binomial divided by a monomial?
Or a basically like where the bottom is a monomial with a x squared y cubed or y cubed x squared. Z.
I got you. I got you. Okay.
Okay, thank you.
So
So when we divide, it all really depends if we have a polynomial on top or a monomial, I can't even say it, on the bottom, right? So the
Well-
polynomial is where like the number is like, there's multiples,
okay,
right?
a monomial is one term.
Right.
If
And
it
the
has more than one term, it's called a polynomial. They tend to call them all polynomials, but if we have at least two terms, okay, then we'll call it a polynomial. So if there's a polynomial in the numerator divided by a monomial in the denominator, and I believe that's what she's requesting, we'll go through and do that. Okay. So let's see here. How about this one? -30 a to the fourth b to the fourth minus 15 a cubed b minus 10 a squared b squared, all divided by -10 a squared b cubed. So Amanda, is this what you're wanting? Something like this?
That's perfect, thank you.
Okay, all right. So we have a trinomial divided by a monomial. In this case, we take each term in the numerator and divide it by the denominator. Be careful that you carry all the subtraction signs and addition signs.
before you go on again, further, the reason why we take the monomial individually by each term of the trinomial, is it because we only have one term on the bottom?
Yes. Yes. So if you try to use the long division process on this, sometimes it gets really messy. Sometimes it works out okay, but it usually tends to be messy doing it that way.
So the reason that the how I would know how to do this individually is just by looking at the denominator.
Yes. If there's one term in the denominator, you do it this way. If you have a denominator like this, where it's two or more terms, that's when you use this long division method.
Okay, got it.
All righty. So back to this one. -30 divided by -10 reduces down to +3 over +1. A to the fourth power divided by a to the second power would be a to the 4 minus 2 power, which is a to the 2 power, or a squared. B to the fourth power divided by b to the third power is b to the 4 minus 3, or b to the 1 power, or just b. So we've got 3a squared b over 1, which could be written 3a squared b. Okay. Now, the next term, can you see that I'm subtracting a negative? So I could change that into addition of the opposite. Same thing here. You okay with what I just did there? Clean up those signs.
Yes.
Yeah.
All right. So now I've got plus, let's see, 15 over 10 would be 3 over 2. A cubed over a squared, a to the 3 minus 2 power is a to the 1 power, or just a. B divided by b cubed is b to the 1 power minus 3 power, which is b to the negative 2 power. Okay. Now in the next step, I've got 3a over 2, but I'm going to take that b to the negative 2 power that's in the numerator and move it downstairs and make it b to the positive 2 power. Any questions there? All right. Next term, plus 10 divided by 10 is 1 over 1. A squared over a squared is 1 over 1. B squared over b cubed is b to the 2 minus 3 power, which is b to the negative 1 power. So that whole thing is just b to the negative 1 power, which I could write as 1 over b to the positive 1 power. And that positive 1 exponent is implied, so I don't need to write it. But I do need to write 1 over that. So that would be the final answer there. Any questions about that? You want another one of those? Or are you okay?
Can we do one more?
Sure. Same pretty much idea kind of thing.
Could you do one where the numerator has a lower number in the exponents?
Then the denominator?
Yeah.
Yeah. Well, yeah, I can do another one of those. That's what happened here. But yes, we'll do that again.
I guess like two, like an A, B, both having those, like two of them. Does that make sense?
Sure. Tell you what, I'll just make something up and we'll hope for the best.
Cool. Thanks.
Yes. So you want two. Yeah. Two variables in the numerator with lower exponents than the variables in the denominator. If I'm
Perfect. Thanks.
understanding correctly. Let's see here. How about this? 15 a to the 8th b to the 2nd minus 10a squared b, we'll just say b, plus 20a b squared. Okay, all of that over 5a cubed b squared. All right, we'll see what happens here. So I have a trinomial divided by a monomial. So we're going to split it up. We're going to have 15a to the 8th b squared over 5a cubed b squared minus 10a squared b over 5a cubed b squared plus 20ab squared over 5a cubed b squared. Okay. So first term, 15 over 5 is 3 over 1. A to the 8th over a to the 3rd would be a to the 8 minus 3, which is a to the 5th. B squared over b squared would be b to the 0 power or just 1. So I end up with 3a to the 5th power. So far, so good? Okay.
Yes.
Minus 10 over 5 is 2 over 1. A squared divided by a cubed is a to the 2 minus 3 or a to the negative 1 power. Okay. All right with that?
Yes.
B divided by b squared is b to the 1 minus 2, which is b to the negative 1 power all over 1. So now I've got 2 a to the negative 1, b to the negative 1, which becomes 2 over a to the positive 1, b to the positive 1, because this equals that, which equals that, and this equals that, which equals that. You okay with that?
Yes.
All right, going on, plus 20 over 5 is 4. A divided by a cubed would be a to the 1 minus 3, or a to the negative 2 power. B squared over b squared would be b to the 0 power, or just 1. So now I've got 4 times 1, which is 4, a to the negative 2 power, which would be 4 over a to the positive 2 power, because a to the negative 2 is 1 over a to the positive 2 power. All right there?
Yeah, I guess I think when the number becomes a fraction with that, when it starts swapping, I think that's when I get a little caught up.
When the number becomes a fraction, so like this as opposed to that kind of thing.
I'm not sure if I can explain to myself to make sense.
Okay.
But that makes sense. Thank you.
Okay, let's explore that just a little bit more. Let's say I've got x to the negative 3, y to the negative 2 over z to the negative 14. Okay, so the x to the negative 3 would go down below and become x to the positive 3. The y to the negative 2 would go down below and become y to the positive 2. The z to the negative 14 would come up above and become z to the positive 14. So basically, you're going to cross over the line and change the sign of the exponent when you're dealing with this context. Okay. If I've got 2x to the negative 4 over 3y squared, that's going to be 2 over 3. Then this is going to become x to the 4th in the denominator. This is going to stay right where it is, because if it ain't broke, don't fix it. It's got a positive exponent already. Is that making sense?
Yeah, it does.
Okay. All right. What else, folks? Anything else you want to look at? Okay, let me refresh your memory on what to do and what not to do. If you have something like that, that is not equal to that, okay, that's a big mistake people make. It's equal to this, which you then have to FOIL together. Okay, and then combine like terms. So be careful of that. That's probably the most common mistake that's made in this chapter, is people do this when it's not correct. Okay, if you had 3x squared, where this was a product, that would be 3 squared x squared, or 9x squared. But when you have a sum or a difference raised to a power, you have to expand it into several factors, however many factors there are, and then FOIL it or distribute, multiply it together. Okay, so watch out for that. Let's see here. You have something like this. That is a conjugate pair, and you can shortcut it if you want, but make sure you've got the plus and the minus, or you can FOIL it out and get x squared minus 3x plus 3x minus 9, and then the two middle terms cancel. I would say if you're unsure about this, that go the long way, okay, if you're still working on that. Okay. Let's see. Can you think of anything else you'd like to look at? All righty. Well, we'll call it quits for the day. I will be back this afternoon at 1:15. I will not be available this weekend. Okay, I won't be where I can get to WebAssign. So like if you ask me questions or extensions or things, it won't happen until probably Monday morning kind of thing, just to let you know. So anyway, but I'll be back at 1:15. So I will stop the recording and